Good day, everyone. So our topic for today is about the arc length and the areas of the circles, sectors, and the segments of the circle. So what is the arc length? So arc length of a circle is an part of a circumference of the circle. So circumference of the circle is 2 pi r or 360 degrees. So what is the formula of our arc length? So our arc length is equals to 2 pi r times theta over 360 degrees. And L is denote the arc length and theta denotes the degree measures of the arc. So you can be used also the formula of arc length. L is equals to theta over 360 degrees times 2 pi r. So now let us proceed to the area of the circle. So the area of the circle is equal to the product of the pi and the square of the length of the radius. So here. So our radius is here from the center to, so to get the circumference of our circle, we use 2 pi r. But if we find the area of our circle, we use pi r squared. So to find the area of the sector of a circle, we will use the formula degree measure of an arc over 360 degrees. So it is a fractional part of the circle. So the area of the sector is equal to the degree measure of an arc over 360 times pi r squared. So area is equals to theta over 360 degrees, which is this theta is denoted as our degree measure for arc. So times pi r squared. So here, I already said that area is denotes A is denoted as the area of our sector, and theta is denoted as the degree measure of our arc. Now let us proceed to the area of the segment of a circle. So a segment of a circle is the region bounded by the arc and the chord of the arc. So how we gonna find the area of our segment? So let us find first the area of our sector DOA, this one, from here to there, and then minus the area of our triangle DOA. So from this, and now let us find this area, this shaded part. So now we'll tackle the examples of the formula that we will use. So in example 1, if the radius of a circle is 12, then how long is an arc of a measurement 45 degrees? Okay, so first, the arc length is equals to theta over 360 degrees times 2 pi r. So given that the measure of our arc is 45 degrees over 360 times 2 pi r. So since we are finding the area of our arc length, right? So 45 over 360 degrees is 1/8. So times 2 pi, and our radius is 12. So it's equals to 1/8 times 2 pi at 24 pi. Now, we already have our length of our arc length, which is 3 pi. And now let us proceed to our example 2. Yeah. In example 2, the radius of a sector is 15. What is the area of the sector having an arc of 56 degrees? So here, we will use the formula of the area of the sector since it is the unknown. So the first step is that so now let us find the area of the sector. So we will use now the area of the sector is equals to theta over 360 times pi r squared. So given that our theta here is um, 56 and then over 360 degrees and times pi times 15 squared. Since it was given that the radius of the circle is 15. So 56 divide by 360 times pi times 15 squared is equals to 35 pi square units. Now let us proceed to example 3. So in example 3, find the area of the segment shown in the figure. So this is our figure, and this is our triangle. This one is the sector, and this part we will be finding the area. So first, let us find the area of our sector. So to find the area of the sector, since in the figure given that we have 60 degrees angle. So 60 over 360 times pi and times the radius, which is 12 centimeter. So let us put here 12 squared is equals to 60 over 360 times pi times 12 squared is equals to 24 pi square units. So now, let us proceed to find the area of our triangle. So before to find the area of our triangle, let us first use the Pythagorean theorem, which is c squared equals to a squared plus b squared. Since here, the hypotenuse is given, which is 12. So 12 squared equals to, and then our base is 6. So c squared plus b squared. So let us find now b squared. So 12 times 12 is 144. It equals to 36 plus b squared. So let us transpose in the other side, the 36, so 144 minus 36 is equals to b squared. So 144 minus 36 is 108. So let us square both sides to cancel the b squared. So to have the value of b, so square root of 108 is 6, square root of 3 is equals to b. Now we can proceed to find the area of our triangle, which is 1/2 times b times base times height. So in here we have different views, so but still the same result. So having a base of 6, square root of 3 times 12, which is this one, the hypotenuse or the height, and then divide by 2. So it equals to 36 square root of 3 centimeter square. So now let us find the area of our segment, since we already have the area of our sector and the area of our triangle. So from the previous discussion, I already discussed that the area of the segment is area of the sector minus the area of our triangle. So we need to input here the area of the sector, which is 24 pi minus 36 square root of 3 centimeters squared. So 36 square root of 3 is the value of our area of our triangle. So let us proceed now to our example 4. So in example 4, we have the problem given that the annular ring is the region bounded by 2 concentric circles. So what is concentric circle? So concentric circle is that 2 circles that have only one center here. So given in this figure that they have only one sector but 2 radius. since in the inner circle and the outer circle has different radius. So now, in the given problem, let us find the area of the annular ring, which is the area in the figure 3. So this part here is the shaded part. So formed by circle whose radii are 5 and 10. So here, area of the outer circle minus the area of the inner circle. So given that the area of our outer circle, which is I know the radius of our outer circle is 10, while in the inner circle is 5. So here, 10 times 10 is 100 times pi is 105 minus 5 times 5 is 25 times the pi. So 25 pi. So 100 pi minus 25 pi is 75 pi square units. So let us proceed now to example 5. So in example 5, here. Here. So in example 5, a crescent is made up of semicircle and a sector. So find the area of the crescent, the shaded area of the figure, this one, this crescent. So if the diameter of the circle is 20. So by the way, class, this form of triangle is the special right triangle, which is the isosceles triangle. So isosceles triangle is 45, 45 by 9. So now, note that our hypotenuse is 20. And then, excuse me. So our triangle is an isosceles triangle, which is I already discussed. So the length of the leg is 10 square root of 2. So now, how we get this 10 square root of 2? So this one, we use the special right triangle formula. So C is equals to A square root of 2. So since our C, which is our hypotenuse, is 20, is equals to A square root of 2. So 20 divided by square root of 2 is 10 square root of 2 equals to A. So we already have the length of our leg. So this one and this one. Now let us find the area of our triangle. So 1/2 times this one, the legs, 2 legs. So 10 square root of 2 times 10 square root of 2 is equals to 100. So let us find now the area of our sector. So given the formula of the sector is that theta over 360 times pi r squared squared. So it's equals to, given that this is 45 and 45, 90, since it is isosceles. So let us put here the angle, which is 90 over 360 degrees times pi times 10 square root of 2 squared. So we have 55. Now let us find the area of our segment. So given that to find the area of our segment, let us have first the value of our area of our triangle and in circle. So in area of our sectors, it is 50 pi minus the area of our triangle, which is we already solved in the first part, which is 100. So now let us solve the area of our semicircle, which is this one. This is the semicircle. So to find the area of our semicircle, 1/2 times pi r squared. So let us use this radius, which is 10, since we are finding the area of our semicircle. So 1/2 times 10 squared. So it is 55. So now we can find the area of our crescent. So the area of our crescent is that area of a semicircle minus the area of our segment. So given that the area of our semicircle is 55, And then in the area of our segment is 50 pi minus 100. So negative times 50 pi is equals to negative 55 minus negative times negative equals to positive. So we have positive 100. So now the area of our crescent is 100 square units. So thank you for listening.